Hello, everybody, and welcome back to our math class. Today, we are going to continue our discussion on the binomial theorem. Namely, we are going to try to build some intuition for the key relationship in between the coefficients. And the key relationship is the one highlighted in red here, okay? But like I was saying, we are going to build some intuition. So in order to do so, we are going to write a few of these binomial coefficients. So, okay, I'm going to write them like so. Okay, here's 0, choose 0. Okay, this would be 1, choose 0. This would be 1, choose 1. Okay, here's 2, choose 0. 2, choose 1. 2, choose 2. And let's write one more row. Well, that would be 3, choose 0. 3, choose 1. 3, choose 2. 3, choose 3. All right. So let me remind you a few things we know about these coefficients. Basically, the definition is n choose k, right? This is n factorial over k factorial times n minus k factorial. And then we actually prove the fact that n choose 0 is always 1, no? So 0 choose 0 is 1, 1 choose 0 is 1, 2 choose 0 is 1, 3 choose 0 is 1. We also prove that n choose n is equal to 1, just because n choose 0 is equal to n choose n. So 1 choose 1 is equal to 1, 2 choose 2 is equal to 1, 3 choose 3 is equal to 1. All right. What else is going on here? Well, let's actually look at computing 2 choose 1. Well, 2 choose 1. This is 2 factorial over 1 factorial times 1 factorial. Okay, so this is actually 2. Okay. Now, we also proved that, remember, n choose n minus 1 is always equal to n, no? So 3 choose 1 is equal to 3. We also proved that n choose k is equal to n choose n minus k. So 3 choose 2 is equal to 3 choose 1. So this is also equal to 3 now. So now I noticed something interesting, okay? Look at these numbers, 1, 1, 1, 1, okay? On one diagonal, we have only ones, and then on this other diagonal, again, we have only ones, okay? And then I noticed that 2 is the sum of the two neighbors above it. 3 is the sum of the two neighbors above it. And so is the case with these 3, the sum of the two neighbors above it, no? Well, I think we actually saw a triangle of numbers like so. It's just that at the time, it was called Pascal's triangle, no? Where, you know, every single, so we've got ones on the outsides of this triangle, and every single number in the triangle is equal to the sum of the two numbers above it. But in Pascal's triangle, that was the rule of coming up with new numbers, no? And it so happens that these numbers seem to be, as you can see, numbers of the kind n choose k. Well, is this a coincidence or not? Okay, for now, we only have intuition. But now, once we realize that this relationship in between the coefficients of the binomial theorem holds, then, and only then, we will be able to say, oh, Pascal's triangle or the triangle made up with coefficients in Newton's binomial are the same thing, okay? So in our next class, after building the intuition as to why we should be looking at a relationship like so, in our next class, we are going to actually prove this relationship. Thank you very much and see you at our next class.